Salam sejahtera and good day, Doctor. We are Group 14 from Section 3 and 4. We will be presenting our application of numerical mathematics in civil engineering. Here are our group members.
My name is Nur Iza binti A. Manja, CF 200167. I'll present about the introduction. In science and engineering, there are many different ways or approaches in problem solving. Thus, they set up experiments to obtain information or data, test hypotheses, and make comparison between theory and practice. The role of numerical method in engineering problem solving has increased dramatically due to the development of digital computers and mathematical software to ease the calculation. Even a scientific calculator enables us to compute more effectively. Next is problem statement. The average annual rainfall of each state throughout Malaysia is based on data obtained by the Rainfall Station of Department of Irrigation and Drainage (DID), available throughout Malaysia. The table shows the average annual rainfall in Johor from the year 2013 to 2018. To conduct the research, the data will be a vital part of the research. However, the data for the year 2017 appear to be missing because of some technical issues. Find the approximate average annual rainfall in Johor in the year of 2017 by using the appropriate method to continue the research. So, the table shows the annual rainfall from the station of Department of Irrigation and Drainage from 2013 to 2018. So, the objective for the study is to analyze the method that can be applied on the problem statement. Next is to apply the knowledge of mathematics to solve the problem statement. So, that's all from me.
Hello, my name is Norli Diana binti Khalid and I will be presenting the methodology. From the problem statement before, to solve it, it is required to use the formula Lagrange polynomials. Lagrange polynomials in numerical analysis are used for polynomial interpolation. For a given set of point x, y with no equal values of two x's, the Lagrange polynomial is the polynomial of the lowest degree that assumes at each value x the corresponding value y. The method was first discovered by Edward Waring in 1779, rediscovered by Leonhard Euler in 1783, and was named after Joseph Louis Lagrange, who published it at 1795. To explain better, I will give you an example. Okay, the table shows the value of x 0.2 till 1.0 and y equal fx, their values. For example, it might ask for given x equals 0.75. Find value of y by Lagrange interpolation. To use Lagrange interpolation, you can only find the value in between those given x's, such as 0.75, which is in between 0.6 and 0.8. For example, if it asks for given x equal 1.2, it would be impossible to use Lagrange interpolation because the answer would not be accurate. To get the answer, you can just key in the values in the formula. For the first order, linear approximation, here it is. The formula for the second order, quadratic approximation. The formula for third order, cubic approximation. The formula for fourth order, quartic approximation.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Dayang Nurul Shakila and I will present for the calculation. For the calculation, the missing data that we need here is for the annual rainfall of the year 2017. So by using the cubic Lagrange interpolation method, so let the data written in a table. Since it is cubic, so we took around the 2017 years, which is only 4 data that we needed until the index of 3. So we took from 2014 to 2018. The x is for the years, and the Y is for the annual rainfall in millimeters. So we continue for the calculation by using the cubic language interpolation. The formula is fx equals to v3x, which is the L0 F0 L1 plus L1 F1 plus L2 F2 and plus L3 F3. So for the L formula we got here is x minus x1, x minus x2, and x minus x3 divided by x not minus x1 times x not minus x2 times x naught minus x3. All this value are equals to the L naught, and we times to the F naught. F naught is y in here, and for the L naught is the years. Wait, x that we need to find here is 2017, and the x1 here, the index 1 2015, x2 2016, and x3 2018. This is for L0 section. For the L1 section, we took the denominator x1 for the L1 section. So we change the x1 here to x0. We exclude the x0 inside this, but we put x0 as the denominator that we need to minus with the x0, x2, and x3. All of this value we multiply together, and then this numerator divided to the denominator, and then we multiply to the f1, which is the value of y1 right over here, 1735. And same goes to the following formula. We just substitute the value of x2, x1, x0, and x3, and f2 and f3 from the value that we got from the table that we have done here. We substitute all the value in here, and then we calculate. So we got the value of L0, L1, L2, and L3. So we put it into the table to make it easier. So L0 here is 0.25, L1 negative 1, L2 1.5, and L3 0.25. So we multiply the y value with the L value together for the naught, L naught, L naught y naught times L naught times y naught, L1 times y1, L2 times y2, and L3 times y3. And then we got the value for the 2017, so that we can conclude that the annual rainfall for the missing data 2017 is 1939.25 millimeters. That's all for me.
My name is Natira binti Muhammad Rusli from session 3 of subject numerical math. Today I am going to present on fila table. So for our problem statement, the average annual rainfall of each state throughout Malaysia is based on data observed by the rainfall station of the Department of Irrigation and Drainage available throughout Malaysia. The table shows the average annual rainfall in the Johor from the year 2013 to 2018. The data will be a vital part of the research. However, the data appear to be missing because of some technical issue. So we solved the problem by using Lagrange interpolation. This problem, we analyzed that the problem is what is the value of rainfall in year 2017. So we got the solution to solve this problem by using by calculate the value of rainfall using Lagrange formula. That's all from me. Thank you.
For the conclusion, most equation plays major roles in the application of science and engineering. It arises in a wide variety of engineering applications that we focus on, especially in civil engineering, for example, structural, hydraulic, environmental, and geotechnical engineering. Those equations can typically be solved by using either analytical or numerical methods. Since the most equations that arise in real life cannot be solved analytically, or maybe the analytical solution does not exist, for such problems, numerical method can be used and exist in the literature. Here in this project, the Lagrange polynomial formula has been used to solve the missing data for the year 2017 that have been observed from the rainfall station of Department of Irrigation Drainage, DID. The Lagrange polynomial provides a convenient alternative to solve the simultaneous that the result from requiring the polynomial to pass through the data values. This is particularly convenient way to interpolate among tabulated values with polynomial.